Good day, everyone. Welcome to Learn Software Development. I am FishFood89, and it has been a while since my last video. Sorry about that, but such is life sometimes. Anyways, I promised in the last video that I'll probably make some theory video about classes and objects and instances. So here we are, as you can see from the screen. Classes, objects, and instances are what we are discussing today. So let's get some theory around the things we've seen around in Godot, and then I'll try to explain some of those things in Godot after the theory part. Let's see how I do. Hope I do a good job in explaining. It's not the easiest concept to understand the first time around. It certainly took me a while to grasp the concept properly. So let's see what happens. So first off, classes. What are classes? Well, classes in this framework is the concept in object-oriented programming, which is shortened or abbreviated as OOP. So you'll see OOP a lot every once in a while, and that means object-oriented programming. So you program so that the objects play the central role in the program. It's, kind of vague at this point, but hopefully it'll become clearer soon. A class, which is the title of this slide, is a blueprint for an object, and that's its relation to object-oriented programming. You could think of an analogy for classes as being, how classes are in biology for species. Like you have the kind of mammals, which is a class, and then in that class you have canines, felines, and other species of mammals in their own classes, and they have subclasses and stuff like this. And just think of the word classification, if that helps at all, to kind of understand what we're talking about here. So it is a blueprint of an object in programming, in object-oriented programming. That's kind of the technical description for it, the best one I can come up with and how I imagine it. And then the kind of term and the concept itself comes from like classification, and you have these certain things that are common to something and they're grouped together into a class. So now let's go to the typical introduction of classes and how it's typically done in object-oriented programming. And here I'm already using the OOP there. So let's get into it. Let's take the example of the dog. And this is a pretty typical and classic introduction. A dog, as we all know, they have certain features. Some of these features are so-called static features, so they're values, they're not actions, they kind of stay in a certain value. For example, the amount of teeth, and those are called as attributes in object-oriented programming. Then there are features which are dynamic, which change over time. They're more like actions, things you can do, things you execute, and those things are typically called as methods. It's a method for the object to do something. So like in language, you'd have nouns, they're a bit like static kind of attributes. Then you have verbs, which describe action. Those are the methods. Hopefully this helps you get a grasp of something. And let's see a few examples of those attributes. For example, the dog's one attribute would be the length of its tail, the amount of teeth, as mentioned earlier, the amount of legs. It's not always a given that each dog has 4. Some dogs might have 3 if they're unlucky, or 2. Unfortunate souls, but that's an attribute still. Technically, that is an attribute even if you had all 4 legs. Method examples, I'd give one example as, wag tail. That's a method, that's an action. Barking is an action. It's something that's interactive, it's dynamic, it oh yeah, dynamic, interactive. Dynamic, not necessarily the best word choice that I have here in the slides. Think of interactive for methods. That would be better. And then run and sleep. These are all things you do. They're actions, so methods. And method is a concept that's really tied to object-oriented programming. We've been seeing in our programming in Godot that we have functions. Well, methods are functions, but the methods are functions which are tied to a class. And they're not standalone functions that are not related to a class. Although in some languages this is a bit obscure and not so clear-cut. For example, in Godot, which I'll get to later here after the slideshow, and there everything is a class, so all functions are methods there. But we'll get to that soon. But now what I'll show here next on the slide is a thing from the Unified Modeling Language, UML, which is something used in software development to describe and document processes. And one such description in UML and a diagram to support these definitions is a class diagram. And in class diagrams, you have classes shown typically like this box. And then you may have, take the mouse here, you usually have the title here and then the inheritance it has. We'll get to that soon. And there's the name of the class, and then you have the attributes, and then you have the methods separately. Attributes might be called as properties. Methods might have some different similar names, but the idea is that these are values and these are actions. And in a true class diagram, you might have in some versions like a line here in between the attributes and the methods. But I wanted to place it here like this so that you can kind of tie the stuff on the left to the stuff on the right. So it's a bit more clear for us when we're learning things that attributes and methods are separate and which ones were which, and not in some technical notation. But this is something that I grabbed from the UML class diagram as a way of describing a class. Alrighty, let's take an example here of these classes. So let's say we just went through dog, and we have the dog class, and then we have a cat class. Well, these dogs and cats actually have a common superclass called mammal. They both belong to the mammal class, as is probably known by most people watching this from biology. Dogs and cats are mammals, so are humans, so humans belong to the same mammal class. Now, if we created the cat class as well, and we actually are able to find pretty much the same attributes and methods for a few exceptions. So there are some things that are common to both dog and cat. And these things that are common typically are common because they share the same superclass. Subclasses of, so dog and cat are subclasses of mammal, and mammal is dog and cat's superclass. And there's a few differences in attributes. Cats, you count the amount of lives they have, and then methods meow and purr instead of bark and wag tail. But run and sleep are common, and the other things in the attributes are common. So what do we do with this thing? Why is it important to see these similarities between cat and dog? Well, this is going to the superclass concept. And it's talking about inheritance, and here it is easy to get confused. I know I certainly got confused the first few times when I tried to wrap my head around this. I kind of understood, yes, inheritance, all clear, but when I saw it in code, I just didn't see how that works. So let's give my shot of explaining it here. Most likely it'll take a few times to really get your mind around it. So in inheritance with classes, we talk about parents, children, superclasses, subclasses, and even base classes. So What's it all about? Well, a parent class is the same as a superclass, which is the same as a base class. It's the same concept, different name. A child class, or children, is the same as a subclass. And the reason why it's used as inheritance is you inherit things from your parent. So children inherit genes from their parents and features, but they have their own things on top of it. So that's kind of where the inheritance concept comes from. And also one other word, which I haven't written down here, is something extends another thing. So for example, a class extends a class. So there, the child is the one that extends from the parent, or then the child has inherited parent, depending on the kind of point of view how you talk about it, but the relationship is the same. But let's try to depict this with a diagram to make it a bit easier. But before that, yeah, what is all of this for? Well, do not repeat yourself. That's a good rule of thumb in programming, to keep your code dry. So don't repeat yourself. As you saw in the cat and dog thing there, we were repeating ourselves. We had same named attributes for the same purposes and same named methods for the same purposes for both cat and dog. And this is where the kind of inheritance that comes in within programming. So how about instead we had first had a class called mammal. And in that, it has all the common attributes and methods of cat and dog and any other mammal. So then we wouldn't have to repeat those because they are inherited to the child class. And this inheritance thing is something I'm really going to try to show in code. But essentially, this is the result that we would then have. So here we have the dog and cat classes, and they are here shown with this notation that I put here with these square brackets that they inherit mammal. This is just to note that this is dog, but it is a subclass of mammal. It has inherited mammal. Dog extends mammal. Extends is a pretty good word for this, which I like, because it means that, well, at least for me, it makes it clearer that we're taking in everything from mammal and putting extensions to it. We're extending it. So I like the word extends, even though the concept is called inheritance. Inherits is a bit like, it feels like it keeps things hidden, like what did it inherit? It's not always that clear, but if you think of it as dog extends mammal, that's actually more closer to how it goes technically under the hood. And that's why I like the word. But then for dog, we just need to give two methods that aren't in mammal, because these aren't common for all mammals, but they're specific for dogs. And then for cat, the same thing. It has amount of lives and per meow, but because of this mention that it extends mammal, both cat and dog have all of the attributes and methods that are in mammal, but we just don't need to write them out here separately because we have this link here. And in programming languages, you usually do something similar to this, like code notation wise, to say that this is extending something, otherwise a computer wouldn't know what is extending. So you do have to be explicit about it in code. And this notation is also from the UML class diagram. Here when you have this kind of a line with an arrow in the end and it's a hollowed out arrow, it says that this is a generalization of this thing. So this inherits this. So this is like the child is pointing to its parent. That's the idea. That's how it's been defined in UML, and it makes sense. Some might say it would be easier to show like, what are my children, but it's just a different way of approaching. At least there's one standard, and once you learn it, it'll be pretty easy to identify these structures from the diagrams. But mammal is a superclass, a base class, a parent. it has these attributes. Any child or subclass which extends / inherits mammal has all of these methods and attributes. On top of that, they have all of their own methods and attributes, if any. It could be that some mammal just doesn't have any extra things that make them more unique, but it might make sense to just call it a class of its own for other reasons. And when it comes to inheritance, typically you can inherit as much as you want in any programming language. So you can have something inherit dog and then some other class inherit that one. So there can be a long chain of inheritance. That's completely normal and pretty common in larger code bases. And now let's go for objects. So we've only discussed classes, but in the beginning I said we'd be talking about classes, objects, and instances. And classes are a big part, a core part of object-oriented programming. So why have I spent all this time talking about classes when I'm supposed to be talking about object-oriented programming? Well, here it comes. Objects are instances of classes. This is the sentence that you need to understand and pick up. Classes, as I mentioned earlier, are the blueprints of the objects. And what are instances and objects? They're interchangeable terms. Some programming languages prefer to say one over the other. I use them 50-50, depending on how I feel, because they mean the same thing essentially. But objects are instances of classes. And that's how classes are tied to object-oriented programming. So for example, I, me, myself here, am an instance of the class human. Kind of makes sense, right? Therefore, I am an object. Yeah, computer science philosophy, okay? Don't mix this with real-world social behavior. No person is an object, but this is just computer science philosophy. So think of this in the way in which computers act, and the bits in there are their objects. And just from a computer science philosophical standpoint, this is how the definition goes in code. And these are the terms that are used. So because there are no humans in the code, they're objects. All right, let's not get mixed up here. Yeah, I know I put this here on purpose just to get someone a bit curious about it. But here you can see that something is an instance of a class, therefore it is an object. That's how it goes. And as pointed out, object is the same as instance. You can interchange those a lot. And in software, we define classes and use them so that we can create objects. That's the concept. And then once we have created the objects, we use them as containers and actors inside the software for interaction. So the classes themselves are just blueprints. This is how it's a manual, how you build this. It's kind of like the DNA, if someone finds that easier to grapple. But with a class itself, you can't do any interaction. It's just an instruction. So that's why you have to instantiate it. So you create an instance of it, which is an object, and then an object, which is not a concept like a class, a classification. An object is something that's tangible, that can interact, like a robot or a car or a dog or something like this. Think of those things. So something that has been spawned out of the class definition. So those are the things that are then used in object-oriented programming to handle the actual interaction within the software. Classes are definitions. Objects are instances of those classes which do the actual interaction inside the program. Let's see how good this does. This is, like I said, not necessarily the easiest thing to wrap your mind around the first time you hear about it. Let's take a few examples. So we have Bruno, and it's an instance of dog. So this is now an object. And since it is an object, we actually have to give values to the attributes. So we say that Bruno's length of tail is 30 centimeters. It has 42 teeth, and it has 4 legs. Cool. That's Bruno. And Bruno can then bark and wag tail and run and sleep, the methods we gave it. Those are the things it can do, and these are its attributes that affect its life. Then we have Bravo, another dog. And its attributes is that it has a 50 centimeter tail length and 41 teeth. It's missing 1 tooth. And it also has 4 legs, so they're both lucky dogs here. All 4 legs are there. So these are now objects. And we don't call these dog, because dog is a name reserved for the class. So we give it a new name, and usually these instances are put into variables in programming. So you say, this variable is an object or instance of this class, and then you call it by the variable, and the variable here is, think of it as a name for a dog, for example, if that helps you kind of bridge the gap here. And then there are more concepts related here, not strictly object-oriented programming related, but other ways of containing data. So as I mentioned there, that objects are used as data containers and stuff like that. Well, we actually have also data classes as a concept. Structures is a thing, data structures. Structures and data structures are essentially the same, but you hear them being used interchangeably, so I thought I'd put them both here. Containers contain things, data, and, well, everything is data. Collections and containers are pretty much the same thing. Arrays are also types of containers or collections, depending on which term you're used to using, and different programming languages prefer one term over the other. And lists. So arrays we see in Godot, but for example in Python, lists is far more common, essentially the same thing. So like in the way they're being used. So we'll go through those later, eventually when we use them, and won't necessarily do that much deep diving into their theory unless I feel it's needed, if I feel like this might be of use or someone requests in the comments. But as I've been saying many times, practice, practice, practice. Do it yourself. So practice is the best medicine for the pains of understanding the theory. So when you've got the theory and you feel like, oh man, what? I thought I understood it, but how is this related to what we're programming here in the checkers game? Well, let's go a bit into that now. So have a break now if you want to and continue later. Or if you feel like you've got the energy, let's just dive into it. The video will just dive into it, but now's a good chance to have a little break and then let this stuff somehow melt its way towards your subconscious memory. So there. Let's get to the code. So I have it loaded right over here. This is where we left off previously. So we manually added all the white pieces and the dark pieces in their own functions. And this is what the code looks like. So what then? What now? How am I going to describe classes here? Well, let's go and look at this. So here we have in main, we took out our 3D world. Here we have this board. Now here you can see board, and it says here type node 3D. If you look at this call out that comes from here, or this tooltip, it says it's type node 3D, and then there's also a mention of instance. Its name is board. Its instance is resource board.tscn. Okay, so this board is of type node 3D. Type is the class here. That's actually types and classes. Those are interchangeable terms mostly. Here in Godot, that's the case. And it's an instance, so an object of resource board tscn. So over here, and it's opened here already for me. Here you can see board.tscn. And this is the row, and its board is made of 8 rows, and then each row is an instance of board row. Row 1, row 2, and they're also type 3D. And here's a row, and then our board row has tiles, and they're of type mesh instance 3D. So you see this mesh type and instance pop around all around here. And let's see if I can demonstrate how this plays out. So here, when we go to board.gd, which is attached here as a script to this one. So in Godot, this board that we see here, this is an object. And the nice thing with 3D is that it actually looks like an object, a board object. And in game development, object-oriented programming comes very naturally because you build a game in a world with objects, characters, items, whatever. And here we have the pieces and the board. So board is an object. Attached to the board, we have a script. Now what the script does in Godot when we attach it to an instance, an object, is that it gives it extended behavior. And that's why here in the script, board.gd, which is attached to the board object, board.gd, board.gd, it's mentioned here, it all ties up. It has here in the top extends node 3D. This is the thing which says that this script is something that continues or extends, inherits node 3D. And node 3D is a class in Godot. And here when we hovered over here, the board, it said type node 3D. So we need to extend our scripts from a class that it is attached to. And essentially, what we're dealing with here is a class. So every script in Godot, in GD script, is in fact a class because there's this extension. And if we went to node 3D, if we wanted to check its documentation, let's go to like online docs here and should open it, I guess. See, I opened it here. All right, so, and we went here to node 3D. And we search for it here. Here we see this inherits. So node 3D inherits node, and node inherits object. And then here's a list of things that inherit node 3D. And there are many things that inherit. Everything in the 3D world essentially inherit node 3D. And everything inherits object, which is a kind of core concept for every object in the game engine. And most basic 3D game object, parent of all 3D related nodes, as described here. And this is the inheritance thing. So that means everything that is of node 3D, it has all of these properties, which I showed as attributes in my thing, and all of these methods. This means, but these are not the only properties and methods node 3D has. Because it inherits node, it also has all of these properties and methods. For example, add child. And let's see, find child, get children, which are very common to use in Godot when scripting. And then node inherits object, which is a bunch of stuff of its own. It's got the signal, get class, get free, emit signal, which is like to emit a signal, or connect signals, which is something that we'll be using as well, to like have events spawned off when something is triggered. And these are actually all at the very base class that's inherited by everything, and everything inherits it because everything we extend from inherits from something that's eventually a kind of child of this, or this is like the grand something parent, the ancestor of all. So that's how that goes. So for example, here in this board script, we have, because of all this inheritance of object and node, we have this add child. As you can see, we've been doing this add piece here, and we had this add child. This add child is actually a method of node, and it's defined in node, if I remember that correctly. Let's see, was that node? Did I lose it already? Nope. Let's see, let's go back to node. Here. So here we had, I believe it was here, we had the add child here. It's a method of node, and anything that inherits from node is of type node and of any other thing. So we'll get to see these in action more as we go on, but this was the kind of the point that I want to show you, that we have a node 3D object here, board, and we know it's of that type because it extends this. It's a type of its own. It's called board. It's got its own functions. This is something we've created ourselves. These functions / methods, they're interchangeable here in Godot, and add piece are things that do not extend in node 3D. So this is so the type of this class is board. It automatically gets the name here. We can also give it a special name by, I think it was class name. I think that's what you can call it, and then you can give it like board, like that, and then it's identified in the engine as board, but it should probably identify like that by default. But it's already a unique class that's a child of node 3D because we're adding it properties, or functions in this case, no actual properties. So the properties would be defined as variables, as we've seen. But these variables here are not part of the class because they're inside this function, so they're only variables of this function. We'll get to see those things later, hopefully, and make it clearer. But this piece, it's not seen outside of this function. It's inside, as you can see from the indentation. And here also, this material exists only inside here. I think it even exists only inside the scope of this, this function. I was going to say is it only in the scope of if, but I can't be sure now. Point being, add child comes from node because of node 3D extending from that, and our board GD script extends from node 3D. So an instance of that, which is the board here, the kind of 3D model board we have here, it has the add child function. So that's the theory on classes and objects and object-oriented programming, and everything we do here in Godot is object-oriented programming. So once you really start to understand these relationships between these classes and what are instances and objects, and the methods and the attributes and how they behave, then you're really starting to get a grasp of what is object-oriented programming, because everything here is object-oriented programming. The whole engine is based on that concept. So that's one of the reasons why I really like Godot and the GD script, because the whole thing revolves around being object-oriented. Also, the way in which you build things is based on that. So that's why I thought this concept deserves a lesson of its own. Hopefully, someone was able to grasp something from my explanation of it. And if not, then go through it again and play around, try things out. But next time, we will most likely be going here and using a for loop. So we haven't used loops yet. So the concept of loops is something that we are going to look at next time, and a debugger will help us understand how it behaves properly. So I'll be showing that as well. But we're going to be able to make this more dry. So do not repeat yourself. If I say I'm making the code dry, that means I'm not repeating myself that much. That means I'm like this add piece is copy pasted here as well. It's 1, 2, 3, 4. It's 12, 24 times. Defined once and then called 24 times, but there's only very few variation on how it's used. So we can actually simplify things and be less repetitive by using a loop. And here the probably for loop is the way to go to solve this thing. So more on that next time. That's all, folks. Thank you very much for your time, and hope to see you in the next video. And hopefully the next one comes with less of a delay. But that's all. Thank you very much. Goodbye.